All right. Good afternoon. Hope you guys are doing well. Just a couple things I want to talk before we get the ball rolling. Um, how many of you are taking the April test? One, two, no, not sure. Three, four, five, six. Quite a bit of students are taking. So, first question I have is there anything you want to ask me?
I wanted to ask about the review. Do you know what time it starts?
Okay, sorry. What did you say?
The time for the review?
The review for the ACT review?
Yeah.
12:30.
Okay.
You have to be here by 12:15. Are you signed up for that one?
I'm gonna sign up.
Oh, okay. Tomorrow is the last day.
Okay.
Okay. Um, and yeah, 12:15. You want to be here. Latest 12:30, I would say. You want to be here 12:05, 12:30. We're gonna lock the center. The 12:45 the test starts. So it's pretty intense, I would say. And I think students who have done their ACT review in the December one, we do only for December and April. They have benefited significantly. One actually told me that he was not our student. He just signed up for the review only, and he went up by 5 points. He said it really helped him to. The fear of taking the test was gone away. He said so. Any other questions? Anything else you have thoughts on? Questions? All right. Any? How many of you done all the homework? Okay, quite a bit. I would say 10 out of 13. Okay, that's not too bad. Uh, okay. Anything else you guys can think of? So just today is March 17th. Then we have class on March 24th. March 31st is off for you guys. Okay. Um, I think it's a Good Friday, I believe. So you guys get Sunday off, and really hope the that weekend you guys will use that to prepare. Really go all in preparation. Then meet back on April 7th. April 14th is another off day because the test is on April 13th. So we wanted to starting this time. We're gonna give the next day off. We've never done that for last 16 years, but we thought we'll try it out and see what happens because students have the attendance pretty poor, and they're like, we're tired and stuff. So okay, and the class goes April 21st and then April 28th. Okay, that's the plan. Um, we believe reading we're done completely. I don't know if Lily talked to you guys. Um, Math we are done at 90%. English we are done at 80%. Science is the one little bit behind at 75%. So, so a little behind in science, but we have time as well. And I think that snow day. Remember, we had that snow day. I think that was the one when we had to cancel and stuff. So, but I think we're pretty well stationed to complete, not only on time but a little bit more than I had planned actually. Anything else? The last probably today is the last chance you're gonna get to ask questions because we won't just have any time after today. Just we'll be continuously going next week onwards. Any concerns? Any complaints? Again, you can be honest with me, okay? If you genuinely have any concerns. All right, Ellen, can you give me a calculator, please? I want everybody to open their math packets. Get your graphing calculators. The first thing I would like you guys to do um, in your calculator, go to mode, go to mode, go to the third one, and make sure it's in degrees highlighted, blinking. Are we good? So you go to the mode, go to the third one, and the degrees should be highlighted. It should be radian and degrees.
Yeah.
So when you guys go to the test, it has only happened once, by the way, where one of my students went with a radian and got 13 problems wrong. So unfortunate. Of course, next time he ended up getting a 35, problem solved. But yeah, so that's how you want to walk into the test with a degrees mode. Okay. Next, open page 5 of the math packet. So one of the most important lectures, one of my favorites as well, is about trigonometry. We're going to go a little bit more detail, law of sines, law of cosines, and stuff like that. So I need complete attention from you guys. When I ask you not to write and watch the screen, and I mean it, that means you're supposed to understand, not just write about things, okay? So is the instructions clear? All right. So get your calculators only right now. Get your calculators only. So today we're going to start from what's called a cast diagram. This was taught to me by this method in my school in India, so I'm going to use that method. Schools here teach a different method, but I can tell you you'll really like it. Okay. So get your calculators. So let's do this I'm going to just do this with the face-to-face students. It's easy. So you'll be doing the sine, you'll be doing the cosine, you guys will be doing the tangent, okay? So what I want from you guys is, for angle 35 degrees, for sine 35, cosine 35, and tangent 35, and I just want you to tell me whether it's positive or negative.
Positive.
Positive. Positive. So 35 degrees is in the first quadrant, right? So all trigonometric functions are positive. Let's do the same thing for 135 degrees. Same, sine 135, cosine 135, tangent 135. Sine.
Positive.
What's that?
Positive.
Negative.
Negative. So in the second quadrant, only sine was positive. The rest are all negative. I just want to also want to talk about this one. So if sine is so sine of x is positive, that means its cosecant x, which is the inverse of this, is also positive. You guys with me on this? So when I say sine, I mean its inverse is also positive. Do 235 degrees.
Negative.
Negative.
Negative. Positive.
So tangent is positive in third quadrant. Got it? So this is 0, 90, 180, 270, 360. Do 335 degrees.
Negative.
Ben?
Positive.
Negative.
Yeah.
So in fourth quadrant, only cosine is a positive. So this is called the CAST diagram, C-A-S-T. So what they indicate the positive values in the quadrant. So a relation between the trigonometric function and what quadrant they fall is defined by this. Many people remember by different ways, by the way. All students take calculus. That's how people remember. All students take calculus. I remember it as CAST, C-A-S-T. Remember the movie Castaway, Tom Hanks, Wilson? That's how I remember. And if you really are some naughty kids are out there, they remember it as all strippers take cash. So, whatever. Okay, I didn't make it, by the way, so I'm just saying. So the point here is, whatever it is, you guys have to know this. Good? First, write down this one. You have to make notes that they are represented in the positive quadrants. And if you have any questions, you gotta stop me and ask questions today. Online students, make sure you ask questions. All right. First question. Try this. Again, as I said, these are all 50 plus level questions, okay? So, if x is between 90 degrees and 180 degrees, and sine x is 5 or 13, finds secant x. Take your time. Once you are done, either raise your hands or do the thumbs up so I know who has done it. And put a big star mark. This is a very important problem for you guys. Anybody? 1, 2. All right, please stop writing. If you know the basics of this, it should take you 30 seconds. Okay? Basics. Why did I give this is the question. Somebody. What is the reason behind this? This will tell me the quadrant it is in. Because this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Sounds good? This represents this quadrant. Second quadrant, sine is positive. Sine is positive. Okay? So it means cosecant is also going to be positive. But the rest all are going to be negative. So I already know the answer that secant x is going to be negative. So I can do a process of elimination and you can usually eliminate 3 in ACT. Got it? That's all I need from this. That's all. Now I've shifted this one. My job is done here. Now I focus on this. Sine x, so I'm going to draw a triangle, right angle triangle. You don't have to draw here, by the way, just simple. Angle x, sine is defined as opposite or hypotenuse. 5 or 13. Yes? You guys good so far? I'm not making a, this is phi, opposite or hypotenuse. Opposite or hypotenuse. And if you do the Pythagorean, it comes to 12 because 5, 12, 13 are the triplets. So, cos x is adjacent over hypotenuse, right? So secant x is flipped of that, negative 13 or 12. How many got this correct? 1, 2, 3, 4, 5. Okay. Questions? Let me ask this one more time. Do you understand why this is given? I don't want you to just nod your heads just to please me. It's not going to make any difference to me. At the end of the day, you guys are taking the test, not me. Okay, good? So this is in a quadrant. What is this is telling me? The ratio, opposite or hypotenuse. Draw a triangle, opposite or hypotenuse, find the adjacent, boom. That's all you have to do. If you do 10 of these problems, you can do this in 10 seconds. And our students are that good. You guys are my students. I expect that. It will take some time. Don't get me wrong. But this is it. If you know this, this is it. I want everybody to do this problem twice, even if you have gotten it correct. Go. Online students, any questions? All right. Question number 2. if pi is less than theta, less than 3 pi by 2, and cosine theta is negative 3 or 5, find tan theta divided by cosecant theta.
Does that say negative 3/6?
This is negative 3 or 5, sorry.
Thank you.
All right, let's get the ball rolling here. So instead of degrees, this time I've given radians range here. So, because I want you guys to be aware of this. So this is 0 degrees, 90 degrees is same as pi by 2 radians. Remember that? We did this. We have done this, right? Radians? Yes or no? Okay, open page 6 of the math packet. I don't want to assume this. I have in my notes at the bottom, converting radians and degrees. Have we done that or have we not done that? In our checklist, it's been check marked, so I want to make sure. No? Yes? Doesn't ring a bell?
I don't think so.
Okay, good. That's okay. Maybe we missed it. So anyway, I'm gonna after this problem, I'm gonna pivot to this then. So remember, we just did this in the calculator about degrees and radians. So 1 feet is 12 inches. Feet and inches are the units of length, right? So just like every measurement has different units, this has different units, degrees and radians. So there's a simple relation. The relation is 180 degrees is same as pi radians. Just like 1 feet is 12 inches, this is the conversion factor. So apologies for that one then. So 90 degree will be pi by 2, 180 degree will be pi, 270 degrees 3 pi by 2, and this will be 2 pi. Right? Because 180 is pi, 360 will be 2 pi. So, the reason I gave this way is so you can identify what quadrant it is. So pi and 3 pi by 2, it's in third quadrant. In third quadrant, tangent is positive, cosecant is negative. Positive and negative. That's all I need to know from this stuff. So, again, draw the triangle. Cosine theta is 3 by 3 or 5. Sorry, adjacent. 3 divided by 5. So the opposite will be 4. Okay? And that negative is already disappeared because I already have told you what quadrant it is. Okay? You don't have to worry about it. That's already taken care here. Tangent theta is opposite or hypotenuse. So plus 4 divided by 3 divided by cosecant theta. So let's look at sine theta, which is opposite or hypotenuse, and we flip it. So negative 5 over 4. So if you solve it, it comes out to negative 16 divided by 15. 4 times 4, 3 times 5. So I should have not assumed this. I thought, I don't know how I may have missed that, but how many got negative 16 or 15? 1, 2, 3, 4. Okay, maybe I should have clarified that one. But is that clear now? And I'm going to go into detail right away. I'm not going to even continue with this till I finish this. This is too big of a topic, okay? Go ahead and write down this, then we move to radians and degrees. So, tell me this. So, did we do terminal and coterminal angles? Reference angles? Does this ring a bell? How come we missed that? So, that is really weird. This is usually our third class. Remember the second was this. So I started with trigonometry. First day was period. No, we met with group as a group. Second day was the first math class. The second math class usually is that stuff. Okay. So we're a little behind than I thought. Any questions on this? Of course, what students usually make mistake is they don't know what quadrant it is. They also make a mistake with not knowing what cosecant theta is. That's the basics, of course. You have to know that.
So how do we know if it's in like the third quadrant if if cosine is negative? Because cosine can also be negative in the second one too.
Agreed. That's why I gave this one. This confirms what quadrant it is. So you can.
Oh yeah.
You cannot just go with the negative here. You can only decide, because remember there are two quadrants where everything will be negative, right? So you cannot decide based on that. You have to decide based on the range. So if I had not given this, and if I expected you to know just by looking at this in second quadrant, no, you can't do that. Make sense?
Yes, thank you.
All right. Now go to page 6, please. I really want to finish this topic. There is a couple of added topics I need to cover before I continue with this. I think you guys are getting a hold of this. I feel that, but the basics are not there yet. So again, don't write anything. Listen up. So, just like we have different units of measurement, same with angles. There's two different units of measurement. One is called the degrees, and one is called the radians. And just like we can convert this as well. And the conversion factor is 180 degrees is pi radians. So what I'm going to do is, before I get to the math part of it, let me explain the significance of this, okay? So I'm going to draw a small circle, I'm going to draw a large circle. Let me ask you this question. Between these two circles, what is common between these two circles?
The center.
The center? Okay. What else? What else is common for a circle?
Degrees.
Degrees. How many degrees is this? 360, right? Whether it's a small circle or a large circle, the total angle is the same, right? 360 degrees. Radius is changes. This is small radius. This is the large radius. But the angle, so let's call R2 and R1, still is 360 degrees, and still this is 360 degrees. Do you agree? So, circumference, which is the circumference of the circle, depends on the radius, right? Larger the radius, larger the circumference. But one thing that does not change is the angle. And you know the formula is 2 pi r, am I right? Circumference, you know where the 2 pi comes from? From this one. 180 degrees is pi radians, so 360 degrees should be 2 pi, and the radius changes, circumference changes. This is the basics of how the circumference formula is generated, was with this one. The angle does not change, radius changes, circumference changes. Sounds good? So 180 degrees is pi radians, so 90 degrees is pi by 2 radians, and so forth. So what type of question you will get on this topic? They'll ask direct conversion factor problems, okay? Before that, go ahead and write down this portion. First question to you guys. Convert 2.25 pi radians to degrees. This was an ACT as is. This was how the question was given in ACT. Okay? Try this. listen up. There's a quick way to do this. When they ask you to go from radians to degrees, you can set up a proportion if you want, right? That's easy. Or, what is pi radians in degrees? 180 degrees, am I right? So, 2.25 pi radians is 180 degrees. Anybody, can you do this?
405.
Huh?
405.
405 degrees. Boom, done. That's it. Or you can definitely set up a proportion that 180 degrees is pi radians. So 2.25 pi is x degrees. You can set up a proportion too. So pi and pi cancels, and you can see it just comes out to 405 this as well. I want you guys to do it this way because it's quick. But if you're not comfortable, go with this method. Set up a proportion this way. Make sense? Good? Yeah, it's not hard, but you have to know this. This was in ACT, by the way. Okay, specifically remember this one. Question number 2. Convert 84 degrees. This was in ACT as well. 84 degrees to radians. The other way around. Convert 84 degrees to radians. I would like to, I know you may have got the answer correctly, but there's a small trick to this I want to teach you guys. So you have to set up a proportion or whatever you want, you're comfortable. 180 degrees is pi radians, so 84 degrees is how many radians? Let's go with x, okay? Just listen up for a second. So you're gonna cross multiply. 180x is equal to 84 pi. So x is equal to 84 pi 180. All right? Okay, good. People get this very quickly, okay? And then they put pi as 3.14, which is totally fine, and you get the right answer, okay? Because pi is 3.14. But what ACT prefers is not a decimal form, okay? I want everybody to get their calculators right now. And I want you to follow what I'm gonna say. Do 84 divided by 180, you get some decimal, am I right? Then there's a key called math, number 1, enter. So math, 1, enter. You got a fraction right now, right? So how do you convert a decimal to a fraction? You just, whatever the decimal is there, do math, 1, enter. So what did you guys get? 7/15. So the answer they will see, you will see in ACT is not a decimal form, but this one. The pi remains as pi here. This is what they would prefer in ACT. So remember one thing with the radians, they keep the pi as pi all through. Good? And if you want to get your calculators, just for your comfort zone here, we can do 7 times 3.14 divided by 15. What do you get? 1.46. Or you can also have 1.46 radians as the answer as well. But I can almost say 99.99% of the times you'll see this format in the ACT. You'll hardly see this. Make sense? So either you go one way, degrees to radians, or radians to degrees. You guys cool? I want to do one more just to get the full grip on this one, okay? Convert 1000 degrees to radians. And I want the answers in this format. I want the answer in this format. And I want everybody to get this correct now. What do you guys got? 50 pi or 9 radians. Did everybody get this? You guys good? If you're not, you just have to tell me. Don't mind explain this again. But this is something very important for you to know. So the previous concept we are studying, if you see anything in pi's, that means instead of degrees they are going radians. But they will have only like 0, pi, 2 pi, pi by 2, so because of the quadrants. Good? Yeah.
So for radians, they won't put the degree sign, but if it's degrees, they'll have to put the degree sign.
Yeah, degree sign has to carry a degree sign. Radians do not have any degree signs. The O or 0 at the top, it's only for the degrees, not for the radians. Good? Good? Yeah, you'll never see like 20 degrees radians. No, it'll be 20 radians. Okay. Next topic. Terminal and coterminal angles. Terminal and coterminal angles. You can stop writing, listen up. So go back to the quadrant again. So, the direction of an angle in an XY plane can produce two types of angles. One is in the counterclockwise, called the terminal direction, which is also called as positive direction. Okay? If I go in this direction, it's called coterminal, which is clockwise, coterminal, which is negative. So let me make it simple for you guys. let's take this angle here. Let's call this as 40 degrees. Okay, look at the direction I draw. Have you seen those arrows? But you may have not noticed that carefully. That has a reason. That says this is the terminal direction, which is plus 40 degrees. You with me on this? This is same as negative 320 degrees. Why? The whole thing should add up to 360, but if I go in this direction, it is negative 320. So every angle in an XY plane can have two answers, which means the same, but the directionality can decide that. Sounds good? So if they ask you, let's say I give you, let's say I give you, this is positive 120 degrees. In the ACT, they'll ask you, what can be other possible angle to this? So what you do, you take in the opposite direction. So tell me the answer. Negative 240. Because the whole thing should add up to 360. You guys with me on this? That's all the directionality. So direction makes it positive or negative. Terminal is counterclockwise, positive, what we're used to. Coterminal is negative, we are not used to it. Right on this. This is how you learn things. You listen, you understand, then you write. In one XY plane, what's the maximum angle you can have? Quick. 360. Remember? One plane, 360. If you want 720, you have to do it twice. Right? Circle as well. Just one more minute. Now I'm doubting everything.
Yeah, I don't know if I learned much in school, if it's her, like, I
Yeah.
learned it in school too. I don't know if I'm mixing things.
I don't trust the school. I'll let me have it, teach it here. If she has not done it, I want to teach it here.
Yeah.
So. You guys good? Okay. So let me start with a simple question. Draw, like when I said draw, something like this, okay? That's what I mean, draw. Draw negative 128 degrees. Draw negative 128 degrees. Negative 128. So negative is what direction? Coterminal, right? Clockwise. So 90 and left it like 38, right? So somewhere around here. Arrow is important. negative 128 degrees. So it is same as what? Same as positive
232.
232 degrees, because you have to add up to 360. Make sense? This is it. Good. Online students, any questions? I don't want to rush. I don't want to go fast. It's all about basic understanding. This is what you need for college, so. Draw positive 1,344 degrees. Positive 1,344 degrees. Okay, so 1,344 positive, and each XY plane can take a maximum 360. So 1, 360, 2, 720, 3, help me out here, how much it, 1080, right? 3. And how much am I left with after that? So 180, 264. So this is 270, 264 maybe here, somewhere here. So something like that. Make sense? This is how you draw 1,344 degrees. Don't draw it only once. You got to show this number of circles. Because if you draw it once, you actually have drawn 264, not 1,344. Make sense? And if they ask the coterminal angle of this one, what will be? If this is 264, so it'll be what, 6 degrees here, something like that? 270, so it'll be 90, negative 96. So if they ask, what's the coterminal angle of this? You get to this point and then do this. So a negative 96 degrees is a coterminal of 1,344 degrees. Was one of them actually. It can be many of them, but it is one of them. Make sense? And you guys are sure that we didn't do this, right? We had not covered this before. Next, reference angle. Reference angle. And you can write this with me. A reference angle is a type of an angle that is always between 0 and 90 degrees. And the reference angle always is from an x-axis and is always positive. this always is positive. Okay, so let me explain what that I did. That's why I have all these things here. So please listen up. This is actually very simple. So let's start with this problem here. So this is the x-axis, right? It's always in reference to x-axis. It's always between 0 and 90, and it's always positive. Okay. So this is my x-axis. This is the angle. This angle, which is plus 40, what I've drawn, itself is our reference angle because it's already drawn as reference angle. But let's come to this one, which is a little different. So it's always between 0 and 90. So if this is 120, reference is always x-axis. What is this angle? Quick. This is 120, so this should be 60, right? It's a straight line, right? 60. So the reference angle is positive. We don't have to even say that. It's understood. 60 degrees because it's starting from an x-axis and it's between 0 and 90. With me on this? So whenever they ask you to find a reference angle, this is exactly what you have to do and then get to this point. Okay? So let's go here. So this is the angle I've given, right? So third quadrant, this is the angle between 0 and 90. What's going to be this angle? If this is negative 128, how much am I left with here? 52, right? So it'll be, reference angle will be 52 degrees. And you don't have to even say positives, it's always going to be positive. Okay. So what's the reference angle of this one? Third quadrant, right? So, was 264, right? So it'll be what? 180 plus 84. So this should be, reference angle should be 84 degrees. You guys with me on this? So to summarize this discussion, this is the best way to imagine a reference angle. It's always from an x-axis, first quadrant, second quadrant, third quadrant, fourth quadrant. This is the direction you have to go and measure them. Make sense? Because it has to be always between 0 and 90. Go ahead and write down this. Try this question. What is the reference angle? What is the reference angle of negative 571 degrees? Take your time. What is the reference angle of negative 571 degrees? as you work on this problem, I want to suggest students who are taking the April test must complete at least 3 full practice tests between now and the test date. Okay. All right. Let me finish this problem here. Negative 571 degrees. So it's a co-terminal direction. So negative 360. Am I right? Arrows are important. So then how much am I left with, by the way? This is negative 360. How much am I left after this? 211, negative, right? So this is negative 180. 211 somewhere here. Am I right? So this is negative 180. And you said 211, right? So it'll be 31 degrees. So this will be my RA, the reference angle, positive 31 degrees. That's the answer. How many got 31 degrees? 1, 2, 3, 4, 5. Online. Almost all. That's good. Does this make sense? So draw the directionality first before you do any of these problems. Make sense? Then you can conclude, and you have to remember from today onwards that when you put an arrow here, it is pretty sensitive to the direction of the angle. So you cannot just willy-nilly do that now because it can change the whole value of it. Okay? Quick few minutes break. Recovery's here. I'll see you guys next week. Bye-bye. It's a good class. Wow.